One of the very useful commands in SQL are those used for finding tuples or certain attributes of tuples that satisfy a specific condition. For example, say in the relation movies we saw earlier, what if we want to find the titles of all comedies that are produced in year 2000? To do that, we query the database. To write a simple query, we can ask ourselves three main questions. Which table do we want information from? Which rows do we want information from? And which columns do we want information from? These questions help us write select from where queries. In other words, every query must have a select clause, which specifies the columns to be retained in the results. It needs a from clause that specifies the table. Then, an optional where clause specifies the selection conditions we want to apply to help narrow down to the rows that contain the desired data. Let's use an example table named Students with attributes SID standing for Student ID, name, school, age, and GPA, and the shown rows of data. Let's first only talk about columns we want information from. First, what about all columns? The query select asterisk from students using the asterisk instead of attribute list corresponds to all table attributes. Which columns does the query select name and age from students would select? As stated in the select clause, this query will return the name and age columns. We can also use as expression and change the name of a column selected. For example, we can select name column as student name from the table of students, and the student name will be the new name for this column in the output of the query. As expression can be more general, including arithmetic or string expression over columns. This is very useful in more complex queries. As a simple example, select age times 365 as age day from students. We'll select the age column, and each value on the column will be multiplied by 365, and the age day will be the name of the new column containing the new values in the query result. Now let's only focus on rows of information and the where clause. The condition in the where clause might be a comparison to a value. For example, where GPA is greater than or equal 3.5 will specify the rows in which the GPA value is greater than or equal to 3.5 as marked. We can use connectives and or and also not in where clause condition. And connective, in analogy to English language, will return rows satisfying both of the conditions, where or will return rows satisfying either of the conditions. Not will negate the condition. For example, where school equals SFU and GPA greater than or equal to 3.5 returns the rows that satisfy both of these conditions. Combinations of such connectives could also be used in the condition statement. For example, the where clause with condition school equals SFU or school equals UBC and GPA greater than or equal to 3.5 will return rows with values matching either of the schools whose GPA values are ensured to be higher than or equal to 3.5. A where clause condition can also include arithmetic or a string expression over columns. For example, the where clause where age times 365 greater than 7,500 will return the rows in the table where the computed value for each entry for attribute age is checked for finding the rows as depicted. Sometimes you may need to eliminate repetitive results from the answer to your query, or you may want to find different possible values for an attribute among your rows. In these cases, distinct can help. For example, in our students table, say we want to find all of the schools that we have student information from. If we say select school from students, this will give us the whole column of a school with all the values. In a real-world application database, this might be thousands of rows and might not help to answer our needs in finding the data. However, select distinct school from students will narrow down the results only to the distinct values of the school attribute and answer our needs immediately.